I've been working with Cooler for about, I don't know, 5 or 6 years. Time flies when you're having fun. So today we're going to talk about storage risks and the insurance implications. And I'm here with my prestigious colleagues. Beth, I guess I can let you introduce yourself first.
Sure. Hi, I'm Beth Hansen. I'm with Greenworks Tools. We do lithium-ion battery-powered lawn and garden equipment and e-mobility devices, ATVs, UTVs, scooters, go-karts, e-bikes, along with your lawnmowers. We do residential and commercial applications. We've been around about 20 years, and we're headquartered in the U.S. out of Charlotte, North Carolina, a little bit north there, but that's where everyone would know, sort of right by Lowe's, if you will. And just had some concerns that we had spoken at an OPEI event, and it made sense to come and sort of talk about, how can we really push the mission of safety, sort of work with the insurance companies to try to assuage their concerns that, there are not 10,000 warehouse fires occurring on a regular basis, and then how do we make sure that we can make it affordable for retailers and manufacturers to store these products, while again assuaging the concerns of the insurance folks that we're not going to cost them a lot of dollars in trying to help should there be a runaway issue.
Yep. And this is Gio Chiarelli, nice
Hi,
Italian
everybody.
Boy from New York.
There you go. So Gio Chiarelli from New York. I'm actually not representing, but here to talk to you about some of the best practices that we're using in Suffolk County on Long Island. So I'm a vice president with the Suffolk County Volunteer Firefighters Association. I'm also a volunteer in the Smithtown Fire Department for the last 37 years. So I'll talk a little bit about what we're doing since the EV and the lithium-ion battery has come to light in our neighborhoods, not just by me, but by you as well. So that's what I'll share with you.
All right, so we could talk about what the concerns are, but everybody here knows what the concerns are. You've seen batteries go up. You know what the issues are, thermal runaway. Will talked about it extensively, so I probably don't need to go through this, but they're just everywhere nowadays, and there's no way to get around it because they're part of our life and we need them. So the whole idea is how do we make it safe? And you can't, when we talk about some of the batteries you're making for NASA, not everybody's going to make their battery the same way. We like it to be that way, but it's not necessarily there yet. I still attend what's called the UN Subcommittee on the Transport of Dangerous Goods. I used to be the chairman at one point, and now I'm in a peanut gallery sitting aside with the industry people. But at that meeting, we're working on a new classification scheme for lithium batteries. So we're trying to make it more granular. So like in the regulations for transport, you have two buckets basically, lithium ion, lithium metal. And we know the chemistries, the form factors, everything is, varies significantly. So we want to regulate batteries based on their inherent hazards. And the way we're going to do that is we've established a test method that looks at propagation. We take 4 cells, we put it in a tray, and we initiate one cell on one end, and then we measure temperature, we measure the amount of gas, we measure the amount of flame, and the types of gas that come out. And then we're going to regulate batteries on that basis, and there's going to be more categories. Instead of 2 buckets, they might be like, we're not quite sure yet. We're still working on it, 4 or 6 or 8 different categories of lithium batteries. So, it's going to incentivize people to design safer batteries, because if you're in a lower hazard category, you will have less regulation applied to you. And maybe some of those batteries, and I represent the medical device industry, they're very small implantable devices, they're probably benign. We light them up and nothing really happens. A little bit of smoke, not much heat. And so it's going to be a better process. But anything that happens at the UN takes a long time. We've been working on it for 6 years. They said they were going to get done in December. No way. Probably another 2 years, but we'll have that system, and then it'll be phased in. And people will have to test their batteries at 100% state of charge, because that makes sense, because it's the worst case. All right. So, you've seen all the articles about batteries blowing up in different facilities, warehouses and such. I've had a couple clients, they were in the e-waste. E-waste is kind of like the wild, wild west, because they don't even know they have batteries in a lot of their e-waste, and then they don't know how to handle it, and they don't do it properly. I had one client in Atlanta, and they burned the whole warehouse down. And then they came to me and they're like, well, oh, DOT's like breathing down our necks. What are we going to do? And, I tried to work with them, and they just really didn't care. They really weren't sympathetic to it, so I fired a client. I just couldn't take it anymore. But this is the problem, that we're seeing all these incidents. Of course, the insurance companies see it, and they're like, well, we got to raise rates. This is a high risk. What do we do? And we see battery storage. Typically, it's on racks. Typically, it's in fiberboard or plastic containers. And then, which regulations do we follow when we're talking about storage? So, unfortunately, there's no federal legislation, no real state legislation necessarily. We have some standards, but they're all voluntary, and they're applied differently depending on where you live, what municipality you're in. So, of course, if you're in California, it's probably more stringent than if you're in Texas. And one of the key things is this International Fire Code, the IFC code. It's under the building codes, the ICC. And in 2018, 2021, they started addressing lithium batteries. Before that, there was no talk about lithium batteries. So the latest code is a 2024 IFC. It's got a lot of lithium battery criteria in there, and they're working now on a 2027, which will come out. But like I said, Texas might be on a 2021 version. And then it depends on who is the authority having jurisdiction, the HJ. What are they going to apply? Do they follow the standard? Do they not follow the standard? And so on and so forth. And the standard industry gets to play a role in there, but you have a lot of fire chiefs, you have a lot of the HJs, you have insurance companies that are participating in the development of that standard. But that standard's really the key, even though there's other standards that apply. So I kind of like this little chart. I didn't invent it. My colleague Mike Pagel, who works with me, did this, but it's kind of like a way to look at the risk. So like if you look at this, you've got 3 different levels: facility level, containment level, battery level. So Cooler's been talking about safer batteries. So that's the battery level, the chemistry, whether there's known defects, what state of charge the battery's at, is there cell-to-cell propagation. So that's the first place that you start. If you have safe batteries, well, maybe the insurance company, you don't need to have a lot of storage requirements. You're already reducing the risk. The next one would be the containment level. So that would be, you got a vented container, what's the energy density of the batteries, what kind of filler material, fire retardant container. That's the safe case, and we're going to see the safe case later on. So that's another risk mitigation measure. And then you get to the facility level. So what type of ventilation, what temperature control, what kind of sprinkler systems, do you have firewalls, what are they rated at, and so on and so forth. So that's kind of a way that we like to look at risk and storage. And my company, we're a consulting company. We go out and we do storage audits and help people to design their storage plans so they can look at the risk, mitigate the risk, and then work with their HJs, work with their insurance companies to try to negotiate what's reasonable. All right, so insurance implications. So, like I said, I'm the executive director of a medical device transport council, and one of my members is Integer. They make medical device batteries, obviously, and Kathy from Integer came to me and says, "Oh, FM Global they're killing us. They got all kinds of new requirements. They're levying on us. We redesigned our battery labs and our facility 5 years ago, and now we might have to go back and put in firewalls, put in a different sprinkler system, lots of different requirements that they're mandating." And FM Global just came out and they just have like these data sheets with recommendations on what people who are using that insurance company have to do. Now, I understand it's a little bit negotiable. It's kind of like, here's what we'd like you to do, but then if you're going to have to go back and spend $10 million to rebuild your facility, you're not going to do that. So risk mitigation, talking about those different levels on how we do it, that could be negotiated with FM Global or any other insurance company that you might be using. So like I said, the FM Global recently updated its property loss prevention data sheet. I've got a link to it. I think we can make this available to everybody if you want to go and take a look at it. I don't have time to go into all the details of it, but it's pretty stringent. And the data sheet covers various aspects of fire protection, electrical safety, and thermal management for managing the risk in the facilities. Also, you have the NFPA. They got NFPA 855, And as I said before, the 2024 IFC code that apply, and it was like it's developed by fire chiefs, industry insurers, other stakeholders. Like I belong to the Rechargeable Battery Association, who Panasonic, Sony, all the big guys were members of that organization. So we get to play a role in there to make sure that it's reasonable, and setting some of the limits. Like, we talked about 80 watt hours that NASA had. I guess that's kind of like old because most laptops now are 100 watt hours. And there's a 100 watt hour exception in the regulations, at least for transport, where it's not as onerous to ship the smaller batteries, lower watt hour batteries than the higher ones. Inconsistently implemented across jurisdictions, and they weren't addressed until just recently. And in 2027, we got to follow that closely and make sure that it's not going someplace that's going to be overly burdensome and onerous. So some of the things that you would see in the fire code, storage in area over 15 cubic feet must obtain an operational permit from the AHJ, has to prove it. Comprehensive fire safety plan, so you have to have a fire safety plan for your facility. Technical report on explosion and fire suppression systems. A 2-hour fire barrier separation from remainder of building, except if using approved prefabricated structure with a 2-hour fire resistance, which could be very costly if you had to put that, or, which is nice, using approved packaging that will contain a thermal runaway. What's that? You get the prize. So, and then batteries kept at 30% state of charge or less, and that's not always reasonable. Like, at least for the medical device industry, we got to have it fully charged and ready to go if somebody's got a heart fest or whatever it might be. So, that's not going to be reasonable. But 30%, the lower state of charge, it's like the fuel in a tank, 30, 50, 100, right? So the more fuel you have, the more volatile it's going to be. And it's been proven over and over again. FAA believes it. They have reports. I've seen it. We'll contest to that. Lower state of charge is going to be safer. Automatic sprinkler and smoke radiation energy detection. So one of the things that my company did is we worked with one of the largest cloud computing companies in the world, and they have BBU batteries, backup batteries. So the power's supplied by the grid, but then they have to have backup batteries because you can't go down without, you got to have that backup. And the fire marshals were saying, well, we want these sprinkler systems in all these cloud computing centers. And we're like, well, what if it goes off inadvertently? That's just going to be a disaster, right? A lot of damaged equipment. So we worked with them to come up with a packaging solution that allowed them not to have to go with the sprinkler systems. It was to convince them that it's a risk mitigation measure. We wrote a report, gave it to FM Global, and they said, yeah, makes sense. You mitigated the risk, so we can agree to that. So, you can work with these insurance companies, and you can work with the authorities having jurisdiction. All right, so alternative means and future code. Ask your fire code official about alternative means of compliance. You can negotiate with them. I just did that with a client recently and said, hey, first thing you do, get them in there. To be honest, you don't want to and the local fire department, they need to know what they're up against if they come in, so they're not blind when they come in. And so, all these things do play into it. Battery storage and transportation solutions. So the Cooler Safe X product line, safe case, safe sleeve, that's a risk mitigation measure that you can apply and use. And then as far as those special permits and approvals with the DOT, I got those for Cooler. And the way we did it is we basically showed them, and there's other people that have these permits, we showed them how we contain the thermal event in the packaging. And we're like, well, how do you test it? They would say, well, what test method do we do? I said, I'll tell you what we're going to do, because DOT doesn't know what they want us to do. So we made up our own test protocol. It actually follows something called the G27 standard. It's a Society of Aeronautical Engineers, and it's a standard that's intended for allowing lithium batteries to be transported on cargo aircraft at a state of charge greater than 30%, because if you transport batteries by aircraft, they have to be 30% or less. And it allows you to put them on passenger aircraft. So in 2016, we had a couple of like serious incidents. We lost some pilots, we lost some cargo planes, and then we just said, we're banning it on passenger aircraft. Makes no sense to put it on there. There's 300 people above in the aircraft, and it doesn't make sense. But there are times, like when you do need to ship it on a passenger aircraft, because cargo aircraft doesn't service maybe an island or some remote area, and particularly with the medical devices that have to get there. So now we have a means of doing it. We have to put in that special package to get it on the passenger aircraft, or to ship it at higher states of charge, which is sometimes necessary. And that's another standard that we worked on for 8 years. The only benefit for me is I got to go a lot of cool places. So, yeah. And part of it was just making sure that I call it damage control, making sure that it's a reasonable standard that you can live with. So there you have it. And I'll tell you, I call myself packaging neutral because I do represent other competitors to Cooler that make packagings. But Will, he was so serious about ensuring that what we're giving DOT covers almost every chemistry they're going to put in there. And then if it doesn't, the best thing to do is to work with a person that's maybe your customer that wants to use the safe case. And if you're not sure that you can contain it, it's approved up to 2.5 kilowatt hours. I think we could probably do 3.5. We just had more test data, and Will's so serious about it and conservative that I was like, yeah, I think we can do it, But he wants to make sure he's got every T crossed and I dotted. But that's kind of how we did it, and that's the battery, knowing what the battery safety is, battery level, and then containment level, and knowing that battery in that container is going to be safe, and that's what they do. All right, I think I'm almost done, and I can turn it over to my colleagues here. Next steps, the rules may not be implemented in your region. You got to know what your AHJs are doing, what your insurance companies are. Just work with them, be prepared to get in compliance ahead of fire inspections. Just work with those local fire companies, and then work with your insurance provider to negotiate rates based on risk. And I won't go into it because I don't want to make it commercial, but that's what we do. We do the risk assessments, and we can help companies to get there. And that's my contact information, and I'll just turn it over to Beth first. One of the really interesting things, sort of as Bob teed up very nicely, is that there's the manufacturing perspective, right? If you're making a safe product, then no problem, right? There's no problem at all. And what you run into, at least in the retail world, from what we've experienced, is that you can make a really excellent safe-ish product, because we all know batteries are inherently not necessarily safe, but you do a lot of things to ensure that they're as safe as possible. If they're handled properly, if they're have the proper containment systems on them, you want to do all of these things to make sure that your customers are not in inherent danger. So some of the challenges that you run into is that not all of the items that are of similar quality, shall we say. And so what you run the risk of, and what I think a lot of the insurance providers have a challenge with, is that they'll have to take care of retailers that are housing all sorts of products that maybe are not up to the same standards as other ones with respect to safety. And so how do you properly make sure that those facilities that have, say, 10,000 different batteries, that some of which are up to standards and some of which are not, that they're properly contained? So once you get that part taken care of, and we can talk about that a little bit later, that you move into prevention. So once you've handled the manufacturing stuff, and it has been really lovely to hear Cooler's commitment to a safe product. It really is nice to hear that, and I hope everybody feels the same way. When you really make that commitment to a product, it really will take you very far, because that's the top of the line thing to be concerned with. But once you've done that, then we know that at least for our company, we spend a lot of time manufacturing a really quality product. So we invest a lot into that. We do fall under one of the
we don't really have we don't store things in a safety containment system in that sense, but we do store everything at 30%. Everything's shipped at 30%, and we store everything at 30%. And I'm happy to say that I'm not aware, over the 20-year history of the company, that we've ever had any kind of DC or warehouse storage fire, and we store hundreds of thousands of batteries. We do, just for clarification, focus mainly on mid-size lithium-ion batteries, so ones that are probably about this big. And then we do have several large platform batteries that go into some of our ZTRs that you plug in, but most of the ones are on a charger. You'll see where you have the little charger that has the fan and you slide it in the like an envelope sort of thing. But those, we spend a lot of time also engineering those to make sure that they don't overheat, and everything is just done with safety in mind and trying to keep the safest of the products. Once we invest all of that, we sort of expect that perhaps there might be a little leniency or differentiation from the property insurance folks, but we haven't experienced that. So a lot of my, one of my points of being here is to make a plea for that, is to try to say, what can we all do collectively to, and as I stated earlier, assuage the concerns of the insurance company, that there are players in the market that really do have a commitment to safety and really want to make sure that you're not sort of lumped into that same product, that same group of folks that don't. And how do we communicate that properly? And how do we just make sure that we're creating the safest environment for everyone? But now if we go past the insurance perspective and you look into prevention, and Gio's going to talk a little bit more about prevention in a little bit, is you're coming at it from a variety of different angles. And you're having to look at how do you educate, at least in our instance, the consumer, to make sure that they're carefully handling the product. These are pretty advanced products. In general, it's not your average Duracell battery, and so you really have to understand how to take care of them. You can't leave them outside. They're kind of, like gremlins. You don't want to put them in water. There are all kinds of things that you just have to be mindful of. And I think that the average consumer just isn't necessarily aware of that. It's really making sure that you work with perhaps the building industry to make sure that the construction industries maybe have to install smoke detectors in garages. It's a simple thing that can really save lives. So it's really looking at working with those folks as well. That's one aspect of it. Then another aspect is really looking at the first responders. Especially when you're dealing with large format batteries in, say, EV vehicles. What are they exposed to when they come across a fire? What do they have to worry about if they're trying to put it out? Not only in extinguishing it, but what are they subjected to with what comes off of after they've extinguished it? If they're using water, what's in the water that's running off of those fires? There are so many different components to that. And then you're bringing in also a lot of competing governmental agencies. The EPA is getting involved in this. What does this look like from a runaway perspective? What does this look like when you have the material that you have that comes after the fire? What happens with that material, and how does that get taken care of? And then you're also working with the CPSC from a consumer perspective, the Consumer Product Safety Commission, to see how do they get involved, and how is it safe for people to have batteries in their house? Is it not? In this constant analysis that we as manufacturers are having to try to deal with. One of the other semi-interesting things that comes out of that as well is that when you have things that come out of lithium-ion fires, is after the fire is out, and however it's been put out, is how do you look at it from a litigation perspective? So everybody always wants to know who's at fault. There was a fire in my garage. I had a battery powered something in there, so it must be the battery that caused the fire. It's always the battery that causes the fire. And the challenge that we run into sometimes with our partner, that's just what everyone says. So the challenge is really also working with our partners that are the first responders to try to understand and make sure that, number one, that's not something that's written down in the first fire inspection report. And I have seen that, unfortunately, sometimes where that's just a go-to statement that's written there. There's been no analysis done, no x-rays. A lot of times you have to x-ray to see if there's been a thermal runaway that was caused internally versus externally. So there's a lot of investigation that needs to go in there. But the challenge is when sometimes those products or things are either too disintegrated, so it's really tough to tell, or they're removed, or something's done to them. We were saying one of the containment things you can do if you have a lithium-ion battery thermal event. You sometimes put them in sand. You can kind of glass it over if it's a small one. But the challenge with that then is that you've sort of spoliated the evidence, if you will. And so having to analyze that after the fact makes it really difficult from a litigation perspective to try to understand that. But so all of those things being considered, it really comes down to, in my mind, prevention. And how do we go about doing these types of prevention things? You know, educating the consumer, really don't believe there's enough out there to really educate the consumer about how the batteries operate, how they need to be taken care of, whether they're large format batteries, small ones. You know, one of the things that we've seen from a commercial application is that there are lots of folks that are maybe smaller shopped, and they tend to like to take the batteries and plug them into insufficient plugs or strips. And so it's not the battery that's causing the thermal issue, it's the electrical strip that they've plugged it in, or they just short out their system. And so they'll come to us and say, well, your product did cause this fire. And I said, well, I don't think so. And the problem is because the short ended up being just in their own system. And so it's about making sure that we are taking the effort and the time to make sure that our consumers are properly educated and that the consumer is actually taking it seriously and understanding the difference in those types of things. So, we and myself especially spend a lot of time trying to focus on how do we improve that communication? How do we get the word out there? And I, again, circling back to the insurance industry, would love to understand how we can better communicate and caucus with that industry to try to understand how we can both be happy without being bankrupted. So that would be really great. And I say that jokingly, but it's interesting now how many insurance companies just don't offer property insurance if you have those products. They just said, sorry, we're just going to drop you completely. Okay. We've had no incidents in 20 years. Doesn't matter, we're just not going to do it. So you really have to figure out, we have to figure out a way to make it work so that, again, the consumers are mostly protected, are protected first most, but that both get what they need. And with respect to further prevention, I'm going to hand it over to Gio.
Oh, boy.
And you can tell he has some amazing anecdotes.
Oh, boy. All right. Hi, everybody. So you can call me Gio, that's me. I have so much to talk about, and we don't have enough time to talk all about it, so I'm going to probably be all over the place, so I'll apologize ahead of time, all right? If you have any questions, you want to catch me later, you want to ask me now, that's great. I don't even know where to start, because I'll start in the middle, I guess. She mentioned a lot about, being able to educate the consumer. So in the fire service, we found that, I guess the EVs is what, the electric vehicles is what brought all of this to light for us, okay? Because we were told you can't approach a car fire, you can't approach a car fire, an electric car fire, in the same manner that you approach a regular car fire. So the difference between an electrical car fire and a regular car fire is that this one plugs in a wall and the other one runs on fuel. Okay, and then you have the hybrid, which goes both ways, right? So the challenge for us is, they told us if you put water on it, that's not going to help. So we're like, okay, well, what else you got? And they go, we got nothing. So we're like, okay. And it's been proven. So we had a fire recently out in Suffolk County. Fortunately, it was further out east where the houses are a lot further apart from each other. They're like 2 acres apart from each other. So this thing was burning. And they put I don't know, how many hundreds of gallons of water on it just to keep it cool. And it never went out because it just kept going. Just like you saw in the pictures earlier, right? So just picture that thing on a table, but now, on a highway. All right, so fortunately the big thing for us is exposure. We got to worry about what's all around us that's going to blow up, that's going to get, taken into effect when this thing blows up, if it blows up. If it just burns, it's not the end of the world, because it'll just take up some tar. It's not the end of the world. But then the next thing is, what do you do with it now after it's been on fire, and luckily if it does go out, now we have to transport it somewhere. So this is another thing. Okay, how do we transport it? So, well, you could just put it in a big dumpster, fill it with water, and take it wherever you want it to go. Okay, so again, if you're out in the suburbs somewhere where, houses are 2 acres away from each other, that's great. What do you do if you're in Manhattan and you're on, Broadway? Where's this dumpster coming from? And where is this payloader coming that's going to lift this thing up and put it in the dumpster? And how are we filling it up with water? So these are some of the challenges we have, right? And we're not going to throw sand on it because it's too big. So they came out with a blanket. Well, put the blanket over it. So now we have to get a blanket. And all the blanket does is just keeps the flames from coming out. It doesn't put the fire out. They said, well, put the blanket on it, then we got this container that has this ethyl methyl good stuff in it that puts out the ethyl methyl bad stuff. So you put the blanket on it, then you get somebody, one of the young guys, and have them go over there and open up the blanket and throw it in there and help take all the ethyl methyl bad fumes away, and then just watch it for about 24 hours. So, this is what's happening in the fire service. So it's very scary. The other part is, what about when there's somebody stuck in the car? Okay? I know as an officer, if I pull up on a scene, my biggest thing is I hope I don't pull up on a scene where there's 2 kids in the back seat and they can't get out of the car and it's got this smoke coming out of it. Do I send a firefighter in there to try to get the kid out, or do I let the kid stay in there? Whose life do I take into my hands and sleep at night? Okay? I hope it never happens to me, but this is what we're up against, folks. So, yes, we're trying to educate the firefighters. It's a hard, long process, okay, because we don't know what to teach them. All we've learned so far is that you can't bring a cutter to that tool, right, and cut the car apart, because there's all those wires that are running through it. And if you cut the wires, not good. So we learn we have to use what they call the spreader tools, and we spread the car apart as best we can and try to avoid all the electrical components. So we do have classes that we can take, that we are taking to educate the firefighters when they pull up on a scene how to take, the extrication process. Okay, but it's scary. Is there any legislation out there that tells these manufacturers to build these cars the same way? No. Tesla puts the batteries under the car. Ford puts some in the back seat and some in the front engine compartment. Chrysler puts them somewhere else. Do people know who are buying these cars that they're sitting on these bombs? No. So what we started doing about 3 months ago in Suffolk County was we said, you know what, hold on. All right, the firefighters, we all know it's dangerous. We all know we got to do things a little different, and we're trying to figure out how to do that. And we're hoping companies like Cooler and other organizations are going to help us figure that out, all right? But we said, well, we're going about this the wrong way. What about all these people that are out there? Okay, we're going to the fires in the garages that are started by the batteries. What about the customer, the consumer? What do they know? They don't know. So we started doing classes. We started educating the consumers. We said, let's sit back a little bit and let's just, for lack of a better word, dumb it down. And, you say, all right, thermal runaway. And they're like, what? Run where? What? Is there a fire? No, thermal runaway. Okay, what is thermal runaway? So we started doing these classes at the local libraries in the different zip codes, and we invited, and we're getting a very good response. We're getting 50, 75 people showing up, and we're educating them. And we're doing something very simple, saying to them, okay, everybody, what is this? And everybody, oh, it's a bottle of water. I go, yeah, okay, come on, help me out. Oh, well, it's water, and it's a bottle. I said, well, it's a container, and it's designed to be standing up like this. And what happens if you do this? Is the water going to come out now? Yes, it's got a leak. That's not good. It wasn't designed to be opened like that and turned on its side. It was designed to be opened and stay like this. So we try to explain to them that's something like what the batteries, they're designed to work in a certain temperature, in a certain type of atmosphere, okay? You can't put a hole in it. You just certain things you shouldn't do with it. And when you got your kid that bike and he falls and hits the curb a certain way, you might have damaged the battery and you don't even know it. Just like I might put a little hole in that bottle, like open the cap a little bit, now when you turn it sideways, that's not how it was designed. So you have to be aware of that. Now we're not telling you that your DeWalt drill is a bad product to buy because it has an electric battery in it. We're just telling you have to learn how to maintain it. You can't keep it plugged in all night. You shouldn't keep it plugged in all night. You shouldn't keep your cell phone under your pillow with the alarm on, plugged in all night. It's not that safe. It could blow your head off and you might not wake up the next morning. Okay, so take that into consideration the next time you do that. So all these little things we try to explain to them that, okay, when you do buy that cell phone, you notice Apple comes out with new wires every time they come out with a new phone. Yes, because they want to make money. But it's the wire that's designed to go with that phone. When you go into the local 7-Eleven and, oh, I should say that, right? When you go into the local store and you buy that other wire because it's 30 feet long and you can take it with you wherever you go instead of just being 2 feet long, but it's not UL approved. And we explain what UL approved means to them, okay? Yes, so your battery drill goes bad and it costs $50 to replace it, but you can go on one of these websites and buy a whole drill for $30 with 2 batteries. But again, it's not UL approved. So this is the type of things we're doing in the neighborhood that you can do to try to help the customer understand so that maybe you don't go to a garage fire because this guy, like we had one 2 weeks ago, the garage is on fire, and fortunately it was the workbench. He had like about a dozen different batteries plugged in that he keeps plugged in all the time, just in case he needs it, okay? So what happened was one of them started thermal runaway, and then it went to the next one, and before you knew it, the car was in the garage, and now the car's on fire, and we were able to save the house, but, you know, he lost a good part of the garage and the car. But it's little things like this that are happening that people just don't even know that they can have it happening in their own house. People, you know, not to get crazy, but, you know, somebody said, well, what about that card that I bought for my grandson that opens and sings a song? Yeah, a little dangerous, but not so bad, you know. If you have sand, you can put it out in case, you know, the birthday goes sideways. But, you know,
Okay.
just some of the stuff that we've been doing that we want to share with you, but we're hoping that we can get more, you know, with the batteries in the cars is really the big thing. And just one more thing real quick, you know, there's no legislation, and the other thing we've done is we're also educating the legislators in the area also. We've come to them and said, you know, we want to show you a little presentation on, so that when they can talk to people like OSHA about what's going on with that, it's a whole other story. But the other piece was there's no placards. You put these batteries in a tractor trailer and ship them somewhere. The outside of the box says that there's a lithium-ion battery in it, but the truck that's carrying them doesn't say that it's inside there. So
Yeah,
we'll
it's
pull
an
up to
exception
a
in the
car,
regulations.
a truck on the Long Island Expressway by us, on its side. We have to try to find out what's going on inside there. If we open that door and we start seeing smoke, run away fast. Okay, that's all I got. Press for time. Thank you.
Well, we can thank the American Trucking Association for lobbying my old agency to not have Class 9 placards. Another thing I wanted to mention is there's legislation that's been approved by the House that's going into the Senate to give Consumer Product Safety Commission more authority to regulate lithium batteries, especially consumer lithium batteries, which is under their watch. With that FM Global data sheet, take a look at it. You know, the problem with that is they come out with a data sheet. Now other insurance companies are going to kind of follow that lead. And I don't think there was a lot of industry participation in developing that data sheet. Maybe they work with some of the people that they're covering, but not necessarily the industry or battery designers and people like that. So we need to be cognizant of that. And that's it. Thank you.